All right, now here are two other situations where perhaps you are given the surface area and your task is to find the volume. Essentially what you're going to do is work the equation backwards to find out what the radius is. Maybe also your job is you're given the volume and your job is to work it backwards to find the radius so that you can then find the surface area, or vice versa. So I want to show you a couple of those situations. What if we knew that the surface area of the sphere was 196 pi? How in the world would we solve that equation? Well, essentially, what we would need to do is make sure that we worked our way backwards to find out what our radius is. And so there's a couple steps that we can take. The first one is to recognize that we can divide both sides by pi. When I divide both sides by pi, the pi's are eliminated. All right, the pi's are eliminated. This leaves us with 196 is equal to 4 times r squared. 4 times r squared. All right? And so what we want to do is then divide both sides by 4, just like we would in our Algebra 1 class. And when we divide both sides by 4, we find out that 49 is equal to r squared. And when we have 49 is equal to r squared, we will take the square root on both sides. If this were Algebra 2, I'd have you take the positive and negative square root on both sides to find the value of the variable. Since we are not going to have a negative radius here in geometry, we only need to worry about the principal square root or the positive square root. And so in order to find r, we are going to take the square root on both sides to find out that 7 is the length of the radius, and whatever the units are. So if it was 196 square inches, then I know that 7 inches is our radius. All right, and then I could use this in the volume formula to figure out what the volume of this sphere that has a surface area of 196 pi square inches would actually be. All right. And so I can do that if I want to, but I don't really want to mess with that right now. But actually, you know what, I will, just for the sake of conversation, because this one does end up as a fraction. So I'm going to ignore this for a second, and I'll go back to that. But if I'm going to now use this to find the volume, then I'm going to be using the number 7 here, which doesn't divide by 3. All right, I'm very aware of that. And so that is going to be an issue for us. We're going to have 4/3 times pi times 343. All right, and now whenever we are multiplying with a fraction, then we can multiply everything else by the numerator and leave it over the denominator, especially if it doesn't simplify. So again, using kind of that elementary, arithmetic here, we need to make sure that we multiply across. This is over 1, this is over 1, if that's helpful to understand. And this gives us 1372 pi over 3. And you can call that 1372 pi over 3, or you can call it 1372 over 3 times pi. But this again is in cubic inches. We want to make sure that we have our units as well. All right? And so if you have the surface area, you can work that backwards to find the radius, and then once you have the radius, you can work that to find out what the volume is. Now likewise, we can have that situation flipped on its end. So if I were to give you, or the exam were to give you, the volume of this figure, and then your job were to find the surface area of the figure, you can do the same task working it backwards. All right, now this is a little bit harder because on the surface area question, we got to take a square root because we know that that is the inverse of squaring. At this point, however, we're going to have to find out how to do a cube root, and that can be very challenging. All right, so I want to make sure that you understand what it is that we're looking for. This is going to be 36,000 pi, and I think I said cubic meters in the textbook example. So we're given this volume, and our task is going to be figuring out what that radius actually is. So we've got this equation. We are going to divide both sides by pi. All right, when I divide by a pi on the left, I'm left with this. When I divide by pi on the right, I'm left with that. Isn't that fantastic? Yes, Mr. Hibbett, that's great. We are going to multiply both sides by 3/4, the reciprocal or the multiplicative inverse of this fraction. And so 3/4 of that is going to be 27,000. And then we have to do this part where we take the cube root. Now, cube root is a little bit tricky. In your blue calculator, if that's what you're using, there is a button right above the, I think that there's the x squared, and then above that it says square root. And then I think above that is a button that says maybe to the x. But the thing that I want you to look for is where it says x root. It has x in the little wedge of that operator. And so what you're going to do on your calculator is you're going to press 3. You're going to need to press the second button, and then that's going to give you the thing that has the x root key in it. All right? This will take the third root of this number. The cube root, which this is new for you. You've not done anything with cube roots before. That is going to tell you that the cube root of that radius is 30. All right? Or I'm sorry, the cube root of that number, 27,000 is going to be 30. It's going to be our radius. And you can confirm that by taking 30 times 30 gives you 900. 900 times 30 is going to give you 27,000. All right, so this number to the third power is 27,000. The cube root of 27,000 is 30. So we've done this work in reverse now. And again, the algebra there holds. We're dividing both sides by pi. We're multiplying both sides by 3/4. Then we have to take the cube root. That might be a struggle with your calculator. And then that gives us our radius. If we then wanted to, we could plug in the radius is 30 over here and compute that the actual surface area is going to be 3,600 pi. So it's kind of a neat trick sometimes when you see those numbers repeated or those numbers in powers of each other. But there is a situation where you're working the formula backwards.